Okay, so I think in last week we are talking about we will already talk about the wireless sensing network first, and in the final of the last week, I think we already show you the protocol regarding the directed division, what we call the double D. Okay, and this is the double D, the basic structure, including some of the very important part. From the first is the naming, okay, and the second one is the interest with the sync, and then with the gradient of the propagation, and final this is the data propagation, and for some of the case, you need to use the reinforcement to enhance the stability of the propagation. Okay, so this is the detail of each step, naming from the data and attribute and value pair. Okay, so by broadcasting the interest, task description based on the naming will be broadcast to the other nodes, and some of will have the query of us the interest, and the sync initiate a query for the interest. Okay, and the query hop by hop diffused to the whole network. Okay, so this is what the first they try to broadcast the interest. Okay, and then task decrease the same. I think the same, but I with the list of the figure you can find the lion is the source. Okay, and give the some of the data to some of the sync. Okay, and the sync may have interest with the data and send a query for to the source. Okay, and then this source will evaluate the gradient to the whole of this path. Okay, and find a very good, or what we call optimal pathway to transmit data to the sync. Okay, and of course for this DD they also need some of the negotiation to make sure that the data can be transmitted and receive. So if we already find a gradient with the optimal one, so this data will transmit. You can find here with the red line transmit from the source to the sync. Okay, and the blue line means that enhance the stability of the transmission. That way, what we call the reinforcement. Okay, so this is the result typically. However, if you find some node failed, I mean cannot pass through the data with the original reinforcement, so the system of the DD will dynamically change the pathway and have the negative reinforcement, means that no more transmission through this node. Okay, so I think this is a very good idea. If this pathway already failed, and we will generate a new one pathway for the data transmission. Okay, so I think this is another one of the recovery from the node failure. Okay, if this one already failed, and we will choose another pathway with another reinforcement to the stable transmission. Okay, so I think right now, mostly the wireless transmission with a different node, okay, is based on the DD, directed distribution protocol. It is very typical one, okay. And next, I would like to introduce some of the hierarchical protocol. The first one, maybe you already know, that is the clustering. Okay, so here I would like to show you two different protocol. One is LEACH, low energy adaptive clustering hierarchy, and TTDD, tier data dissemination. Okay, so the first one, LEACH, you can find this is a different way because we right now talking about a hierarchical protocol with a very large nodes. So here you can find this is the data sink, and here are some of the groups with the cluster member and the cluster head. Okay, so this is a typical node transmission based on the wireless sensing network. Okay, but I think I want to talk about very in detail how about the leech transmit with some of the handshaking mechanism. But I would like to say you just follow the idea of this. I think for each cluster, they may use also the DD, direct diffusion technology for the wireless transmission. But however, you can find if I have several cluster, and so finally you may need some of the hierarchical transmission for the top sink, data sink. Okay, so another one is TTDD, but this one is another concept. You can find if I have so many nodes in a different place. Okay, so you can find here for the case, this is the source, the B point here, and this is a sink. Try to send a query and receive the data. So how can we do this kind of the very large and diverse the cloud, what we call the cloud? Okay, so the first step, make sure where is the source, and the next step, the second step, try to have some of the virtual grid. I mean, I use this virtual grid to divide it, all the nodes into several cluster, okay? And for each grid, we will assign one of these as OK, coming taxi， 你先做一下，我们待会再。OK, and we will assign one of these member as a cluster head. The other ones is a class member. So unlike this, we use the virtual grids to divide into the different cluster, and each cluster have a cluster head for the transmission of data into the sink, Okay, so I think this is the maybe what we call a geographic routing, much efficient to transmit the data to the destination. Okay, and this is the concept. Okay, if you try to just have the what we call the greedy forwarding transmission. Okay, and for this kind of the geographic routing, especially every node knows its own location. Okay, so I think this is very important in the beginning. I mean, each point have the coordinate x, y, and z. So everyone knows his location. And we can use this is the source with the gridded forward to the next. I mean, we have the range of the transmission, okay, to the Y. And the next use the Y, also use the greedy forwarding to the next, to the next, and so on to the final, to the destination, to the destination. Okay, so I think this is the concept of the greedy forwarding based on the geographic routing. Okay, so you can jump to the destination, and of course, maybe you need you will say, what is the optimal path? Optimal path to the destination. So there will be another issue. Sometimes the greedy without the optimal pathway, he said we will lead to the dead end. Means that when you transmit to here, and this one never have the next step to the destination. So we will have a dead end, dead end. Okay, so this will be the problem for the typical greeting forwarding. So I would like to say that this is I just introduced several of the very typical wireless routing protocol, but you can find, I just show you the basics. So there's some of the modified and advanced protocol based on this typical one. But I think this will be included in information technology in the future. Okay, so here this is one of the solution using a combination of the greedy routing and phase routing. Okay, some of the another optimal way, okay, to avoid what we call a dead end. Dead end. Okay. So I think here I just have a very quick summarize of the different protocol for the wireless sensing network. From the first, very easy one, flooding. I just broadcast the data to everywhere. This is routing. Gossiping, much advanced one, and the direct diffusion leech. Okay, this is what we call a DD. Okay, and the leech, and here this is the what we call a hierarchical structure for the complex one wireless sensing network. So I just here to show you the classification, the position awareness and the scalability, mobility, power usage, and the data aggregation, and also the query base. QoS is the quality of the service. Okay, so mostly it is used for the make sure that your data can be received or transmit to the another node. Okay, and this is another table that I think you can use the different kind of the application. For the first one, the habitat monitoring. If you try to find some of your dog, and you need to use this, and suggest the protocol of the wireless sensing network. So maybe for the environment monitoring for this class, DD will be sometime maybe used for the monitoring in the environment. And for the other one, health, okay, maybe you can use the leech, the hierarchical structure for the wireless transmission. And also for the military, okay, there's another one of the GAF. This is a new one. And so on for the home or office. Anyone use some of the intelligent, the light or the outlet in your home? No, not yet. Okay. So right now, in Taiwan, we just try to promote the digital digital the recorder to understand the power usage in each house. Okay, and this digital one can transmit the data to the company, and so you can understand actually the real time the power consumption in your home or in your house. Okay, so this is the typical one, but I think of course we are not the domain knowledge expert for this wireless sensing network. But however, I think we just introduce this for the very quick understanding. If you try to have some of the project and need some of the maybe more than 10 or 20 nodes in a different environment. So in that time, maybe you need to think about what is the best way to choose for the wireless sensing network. Okay. And the next, I would like to show you some of the low power wireless transmission. Okay, so here I have some of the requirement. You can think about distance, power consumption, bandwidth, cost, communication cost, numbers of the base station, transmission delay, and the penetration. So maybe I don't know. I would like to ask your first cell phone, which type? Nokia? No? Motorola? No? 你们第一只手机是什么 ？Sony Ericsson. What is your first one? Samsung. Okay. No. Which one? Nokia. Nokia. Okay. And BlackBerry. But it is mostly used in Europe or US. Okay. Motorola. No. Okay. 20 years ago, I have my first cell phone, Motorola. Okay. And I remember that because I have that cell phone, and later we have the earthquake, GG earthquake, 20 years ago. Okay, so in that time, in that night, some of the cell phone is very useful when you try to report your status to your family. Okay, but in that time, maybe most cell phone cannot be used because we already have the very big power shutdown over the whole Taiwan. Okay, and before the cell phone, do you ever use the what we call the BB code, message transmission? Okay, what is that? You can type. When someone try to find you, okay, they will call to a company. Okay, and that company will say, "Oh, what is the message you try to send to to me, for example?" And then if I have a BB call, it is the messenger, like the message. One of the telephone number. So if you receive that, you can find a public telephone and call to the original one, right? Try to find you. Okay, so this is a BB call, like your messenger, Facebook Messenger. Okay, very useful. Okay, so before the cell phone, I have that one, maybe 1 or 2 years. Okay, but I would like to say right now, in the beginning of the cell phone is the 1G. 1G, what is the 1G? 1G is mean like the analog device of the cell phone. And the second G, 2G, is mean that advanced to close to the digital one. And right now we have 3G and 4G. Okay, so this is with a different transmission bandwidth. Okay, and right now we have a 5G. So maybe in the end of this year, we have some of the application of the 5G. But you can find for the typical cell phone, you can have you need so many of the base station. Okay, I don't know, in Taiwan, the base station of the cell phone is sometimes installed on the roof of the building. Okay, so maybe next time you can find some of the antenna, several antenna on the roof of the building. Okay, and of course, right now you can find if you try to have unlimited transmission of the cell phone, you may have a very higher communication cost, and of course the chip cost. I don't know. For my first cell phone, maybe thousands of the NT dollars, and till now I just read the new product from the Sony. It's about 30 to 35,000 of the cell phone. Of course, if you use the Apple iPhone, they're already more than the 50,000, right? 50,000 dollars. Okay, very, very expensive. And of course, for the 4G and the 5G, it is very famous with the higher bandwidth. So you can transmit the data in a very short time with the very high bandwidth. But you know that the power consumption with this kind of the cell phone, you need to charge every day, right? For my first cell phone, the Motorola, or the next one, Nokia, I think I can use that more than 1 week without the power charge. Okay, and but you can find this is the red one is your cell phone, but here the green one, maybe later I will show you the Zigbee, a very short like the Bluetooth. It is a Zigbee with the IEEE protocol. It is a very low power consumption, but of course a very low bandwidth for the data transmission. And I would like to say, no more communication cost. Why? Because the Zigbee is the private. If you already buy of this Zigbee, you can transmit the data without any fee, and very cheap. But however, it is just used for the very low message, a very short message, because of the limited bandwidth. And right now, we have a new one of the low power WAN. Okay, it is very unique, especially for the very long distance. I mean, for the Zigbee or the Bluetooth, maybe 10 to 100 meters of the transmission range, right? Okay, but for the low power WAN, for example, the LoRa, right now you already use the LoRa. Okay, this kind of the LoRa or the low power transmission, for the specification, it can be used more than 10 to 20 kilometers for the data transmission. So means that we have a very high penetration to everywhere with this low power WAN. But however, you can find the transmission delay is much higher, okay, because this is the long distance range transmission technology. Okay, so I use another chart with every time I would like to encourage all of this student. Every time you see a picture of this kind of the chart, you need to understand what is the X and the Y first. For the X, this is the range capability. And for the Y, this is the bandwidth required. So you can find here, this is the cell phone system. And here, anyone know what is it is? A02.11 AC or AD or N or ABG. Anyone know like this? This is the different kind of the Wi-Fi. Okay. You said Wi-Fi or Wi-Fi. Okay. I already heard two different pronunciation. Okay. And here you can find a very short bandwidth and a very short range is the Bluetooth and the RFID or the Zigbee here. But however, today I would like to introduce the low power wireless transmission with the very long distance of the transmission, but still a limited bandwidth for the data. Sorry, this is in Chinese, but I would like to say this is the transmission distance, and this is the power consumption, and what is that? The power consumption just without the transmission of data, and this is the battery. If you use the 2000 milliampere battery, I mean like this one, and how longer will it survive? So you can find for the 2G, 3G. Right now we don't have this. We have the 4G. Okay, so actually, like the cell phone, you need to recharge every day, but the distance depends on the base station of the cell phone. Okay, but for the Wi-Fi, maybe 100 meters. Zigbee, less than 100 meters. But for the LoRa, more than 50 kilometers. And with the very low power consumption. So meanwhile, I would like to say, so you can use this maybe one of the very big battery for the data transmission more than 1 year or more than 1 year, up to the 5 to 10 years. Okay. So I would like to say the first one, I would like to introduce the Zigbee first. Okay. So this is from the IEEE. Anyone know that is IEEE? It is electrical engineering. Like the ASCE. Do you know the ASCE, American Society of the Civil Engineer? Some group like this. Okay, so for that one, actually the Zigbee developed from the 2004. Okay, so I would like to skip this one because it is too in detail. But I would like to say, in that time, why we try to develop the Zigbee, because we try to have a requirement and on the low power consumption and the low cost. Okay, because we already said that smart dust in the beginning for some of the IoT. Okay, right now is what we call the IoT, Internet of Things. Okay, so if we try to achieve that goal, we need some of the very low power consumption and the low cost of the data transmission. Okay, so in that time we developed Zigbee, and there's two types of the Zigbee. One is the full function device. The other one is the reduced one. And the full function device, I would like to say, can be used any routing protocol and can be assigned as a coordinator. What we said, it is like the cluster head. It is charged to transmit the data, maybe in a cluster. That is what we call a coordinator. Okay, and the reduced one just transmit the data. Okay, so here I would like to say to form ZigBee, we have some of the topology. Here, that is what we said, the full function device, FFD, as a coordinator in some of the cluster, okay? And here, this is the peer-to-peer structure, okay? Point or tree. Okay, so for this kind, you need 4 function device to everyone, because every node can transmit the data and receive the data, receive, transmit, receive, transmit. Okay. I think I would ignore of this because some of the model already have some, I mean, based on of your quality of the service. If you try to have a very high quality of the service, you need to make sure that the handshaking, I mean the negotiation between 2 nodes is very important. So let's make sure without any data leakage. Okay. So I just ignore here because if you have interested, you can find a very in detail in the documentation of the ZigBee. Okay, so let us have a re-overview of the topology of the ZigBee again. Here, this is a star. So I have a coordinator in the central. Okay, and here this is a router. Okay, and also have a coordinator and a router here. And this is a tree and with the end device. So with a different kind of the structure, okay, of course you can use a different kind of the protocol if you try to make sure that the data transmission efficiency. Okay. So I would like to say ZigBee, right now you already know that we have 3 kinds of the ZigBee. One is the coordinator, and plus with the cluster, maybe you need a router. And this is the end device, just transmit the data to the router, and finally to the coordinator. Okay, so this mesh you can find, and I would like to say I just ignore here because some of the algorithm can be used to estimate the address to the ZigBee. Every ZigBee knows in a mesh. So this is a typical one. Okay, you can have a different address to the different nodes, and you can estimate the depths to the from the one node to the another one. Okay, just ignore that. Okay. So this is the same. You can use the tree or the cluster routing in the first cluster area. Okay, and this is the mesh. Okay, using like the grid for the data transmission. Okay. So I have a very quick summary of the ZigBee network. Okay, from the different layer, from the start and through the tree, and finally to the mesh. Okay, you can have some advantage and disadvantage. Okay, so right now ZigBee actually if you try to buy some of the intelligent or smart home device, most of them use the Zigbee because just as I said, Zigbee can be used for many, maybe the range less than 100 meters. Okay, so for your house or for your home, if you try to control the light bulb or try to control some of the power outlet, you can use Zigbee for the data transmission. Okay. And in the meantime, I would like to say there's another technology or the other protocol, what we call the Z-Wave. Do you know that from the video tab, we have a competition between the beta, what we call the beta is developed by the Sony, is a smaller one, the video tab. And VHS is a bigger one. I don't know, maybe from the other company. I don't know. The small one I know that is a Sony. The bigger one is CHIH. I don't know. I forgot the company name. But finally, the VHS, the bigger one, win the award. Okay. And for the next, I would like to say for the latest one, right now you already know that the BD Blu-ray. Actually, in the same time, there's another technology, what we call the HD. HD, it is developed by the Microsoft and some of the other company. And the Blu-ray is developed by the Sony originally. And finally, okay, Sony win the war. Okay, so you can find this is sometimes every new technology or the product have the different kinds of the technology, but finally we will choose one of the for the as a popular one. Okay, so the Z-Wave is a loser for that time. Okay, so right now you cannot see so much product based on the Z-Wave, but I think the Z-Wave is similar with the Zigbee. Zigbee. Okay. And the next, I would like to show you from this maybe 2 or 3 years, we have a new technology of this long range and low power consumption. The 3 famous one, Sigfox, and the second one is LoRa, and the third one is the NB-IoT. I would like to say the Sigfox and the NB-IoT will be much similar. The LoRa is another one. But what is the difference? LoRa, just I show you, because I already give you some of the chip of the LoRa and antenna, right? Means that for the LoRa, I can build our own, I mean the wireless network. Okay, because if you have a chip, if you have antenna, so that chip can be just like the Zigbee. As I say, we have 3 types of the Zigbee. Okay, everyone is the end device with the LoRa chip. And we need a coordinator for the LoRa, what we call the gateway. So you can build your own and private network with the LoRa. It is developed by the IBM first, and the full name is the long range signal and control. Long range and signal control. Okay, and I would like to say for LoRa, it is used about 2 main kind of the frequency. One is about 800 to 900 megahertz. Okay, and the other one is about 500 megahertz. So with a different country, you can find the different frequency domain they use for the LoRa. So sorry, you can bring the low hertz. Okay. But I like to say, just I say, LoRa, you can build your own with very long range distance, more than up to the 10 kilometers, and with one of the gateway. But it is the ideal case, right? Because you can find if you put in a slope, maybe you still need the long length of the antenna for the data transmission. Okay. So I just think just introduce some of the LoRa technology. And right now, the LoRa have three kinds of the mode for the data transmission. I'm sorry in Chinese, but I would like to change to the English first. Okay, actually, LoRa can be used for the uplink and the downlink. It is the dual directional transmission technology. Okay, and we have mode A, mode B, and mode C. This is just regarding the quality of the service, or quality of the service. Okay, so actually, if you try to make sure the very low power consumption, maybe you need to use the mode A. And of course, if you choose the mode C, mode C will ensure your data transmission can be received safely. But however, mode C may have a higher power consumption or power consumption. So just as I said, you can build your own private. This is the gateway from the different location, and with the node here, just like the cluster. So you can build your own the LoRa mesh and system by yourself. So actually, this is sometimes can be used in the company or what we call the infrastructure, like the bridge or the building monitoring. Or you can find it can be used for the farm, healthy, and wind turbine, and of course the car tracking. Okay. And we already have some of the product already. I already show you in this kind of the LoRa WAN. It can be used a very big area. But however, if you try to use a small area, you can use the P2P, point-to-point cloud. And the next, I would like to show you another two. One is the Sigfox, the other one is the NB-IoT. What is that? It is also based on your cell phone technology. I mean, you still need a SIM card. Every device need to rent a SIM card from the telephone company. But you can use the very low fee, maybe 1 month, maybe 20 or 50 NT dollars, because what is that? This kind of the Sigfox or NB-IoT supposedly transmit the data with a very short length and a limited time interval. I mean, you can send a message once a day. So overall, in this month, maybe we only need $20 for the data transmission. Okay, but however, I would like to say this kind of the Sigfox or NB-IoT, one thing is that you need to rent from the company. You cannot build your own the mesh work. So the Sigfox is most used for the commercial one. Commercial one. This is the high-end commercial. And also use the 900 megahertz for the data transmission. And for the NB-IoT, the full name is the Narrowband Internet of Things. Okay, so you can find this is a narrowband. I mean limited the bandwidth for the data transmission. But just as I said, you need to rent a SIM card from the company for each device. So here this is just the comparison between the LoRa and the NB-IoT. I'm sorry in the Chinese, but I would like to say very quickly. For the NB-IoT, you don't need to build the gateway by yourself because it uses the base station of the cell phone. So you just rent a SIM card and install on the device directly. Okay. And maybe Ferry, later in a time break, can you find the two of the NB-IoT device? Okay, bring to here. Okay. And do you have some of the Zigbee device? Please find one Zigbee. Okay. All right. So both of these NB-IoT and LoRa can be used a very long distance because you can find the NB-IoT use the cell phone technology. So you can transmit from the data from the Taipei to the Kaohsiung directly. Okay. So this is I think the detail in the different IEEE technology. Okay. So the first one is the Bluetooth, and here this is a high rate for the data transmission, especially using the cell phone technology, and the low rate like the LoRa. Okay. So here I just have a very quick introduced for you to understand in the basics of the wireless transmission. Okay, and I think maybe we can have a 5 minute break, and later I will ask my student to show you how to use the Raspberry integrate with the camera. Just I say, I supposedly try to have your own practice, but right now the camera not delivered to Taiwan yet. Maybe next week we can have a practice. But I think later I can have a very short video for the demonstration. Okay, let us have a short break. Okay. 你可以看要怎么架起来用。你是用录影的吗？没有。OK， 那你先架起来好了。你可以用这个吗 ？OK， very please find the Zigbee and the NB-IoT. OK。不用没关系，你要用也可以啊，你要用也可以。因为我把那个过程拍下来。你都拍下来了。OK。你可以修一下，主机是在这吗？对，待会可以直接修吗？我还没装。你现在装没关系，现在装，也就给大家观看一下。你提醒我，最近我早上有一篇论文是讲有关于热对于岩坡的影响，造成岩坡破坏的影响。热就是热，对，我待会晚一点下载下来再传给你。